The next presentation is from Alex Lee, who is Senior Director of Global Product at LONGi Green Energy. Alex is going to talk on the new era of utility solar powered by LONGi BC technology. Alex, the floor is yours.
Thanks, Shaban. So first of all, let me try to share my screen and my greetings from China. And I'm seeing that, I was scrolling over the audience list. I'm seeing a lot of, familiar names from our industry. And please, greetings from China. This is Dr. Alex Lee, serving as the Senior Director of Global Products from LONGi. And I'm seeing that, there are a lot of friends from around the globe. Some are from Europe, some are from Australia, hi Australia, and some are from China and India as well. So I'm seeing that, pretty much a lot of audience from different continents are quite interested in what we're going to talk about today. And I am basically the product director of back contact product from LONGi, in charge of the product development, product planning, and you may consider myself as the babysitter of the back contact as I'm online from LONGi. So I guess I'll be able to deliver a fun and interesting story about how the history of BC and how we're gonna reshape the utility future for BC. So today I'm gonna talk about quite a few things and hopefully the evolution of solar cell, the unbeatable ceiling of back contact, the excellent generation yield, and the leading product values. And of course, we will have other talks about from Chris talks as well. So I would like to start my sharing about my story about back contact and why we are doing back contact products, in contrast to the other competitors in the market. So first of all, I have to say that the majority of the product from the market is based on the TOPCon technology. But as we are all from research, most of us are from research. What you would like to do to improve the TOPCon technology? Let's say from the very beginning, you start from the very standard TOPCon on your left-hand side, right? On your left-hand side. So basically, what you would do to improve the TOPCon technology in terms of the efficiency is to find out what would be your biggest loss for the TOPCon. The answer is that for TOPCon, the biggest loss comes from the ultimate high temperature diffusion, boron diffusion from the front side, as the red part on your left figure. That diffusion occurs at over 1,000 degrees C, and that's gonna introduce tons of impurities as the boron defect, which is the biggest loss for your TOPCon efficiency. What you do is to replace that biggest loss as a high temperature diffusion with the passivating contact. You will have the p-poly and the tunneling oxide on the front side. So in which you kind of have a dual poly TOPCon structure, which will enable you to have an ultimate high open circuit voltage. But what will be the downside with such a structure as shown on the second graph here is that the dual poly structure, yes, it is beautiful and it is excellent, but the downside is that you're gonna lose a lot of current due to the parasitic absorption from the polysilicon. What you would do is to ultimately, you would like to have the polysilicon only where you have your metal contact. So what you do is to use a laser as a third graph here to perform a precise laser patterning to enable you to process your polysilicon only underneath your metal. Where you don't have your metal, which is light absorbing, you want it to be as transparent as possible, such that you can boost your current without losing your passivation quality. So if you're on your fourth figure on your right hand side here, basically you will have the ultimate structure of the front and back TOPCon. So if you look at the process flow here, review the process flow here, it is quite similar or almost identical to the back contact cell. You will have quite a few steps of the precise laser patterning. So let's say your process is mature and you are lucky enough to achieve your ultimate structure of your TOPCon. So what you would do after is to find out what is the biggest loss. Again, if we have done substantial, power loss analysis on the ultimate structure of TOPCon to find out what will be the biggest loss of efficiency. The answer is that ultimately, on your left figure here, your preservation is almost perfect. There's not much you can do about preservation. Then what you would do is try to reduce the shading impact of your metal on the front side. Now you will have two approaches. Number one is to move everything to the back side to reduce your metal, to reduce your metal shading, or otherwise, because you are trying to reduce or basically mitigate the shading loss, the shading loses from your metal. The second approach is that you find a metal material, which is transparent. Well, to the best of my knowledge, there's no transparent metal to the universe that we are living in. So the only approach to solve that dilemma is to move everything to the website. Let's come back to the ultimate structure of TOPCon again. When you're trying to further increase your power or your efficiency, you are basically trying to reduce the shading of your metal. Another approach is to you try to reduce the metal shading by shrinking your metal to reduce the area of your metal. But the downside is that if you are reducing the width or the thickness of your metal, then you are effectively increasing your series resistance of your metal. Now you are seeing that you're in a dilemma that the optical losses and the electrical losses, they are kind of coupled together. You cannot improve one thing as well as improving the other one. You are in that impossible triangle that there's not much you can do. And that's why in our research and from our analysis result, our end game strategy is to move everything to the back. Now you are able to decouple your optical and electrical component such that you will be able to have your ultimate excellent surface preservation as well as you have no shading losses from the front side. And that is the ultimate solution for us in terms of the single junction solar cell. And that is the fundamental reason why LONGi has been dedicated to improve and develop the HPBC 2.0, as in the HIMO 9 product. So the second part is that to deliver a world-class performance of HIMO 9, we are able to deliver a maximum power of 670 watt, a mass production average power. As of today, we are able to reach 655 watt. And to demonstrate further on what we have done and what we have improved, I will go through several pages. So we have received a lot of questions from the market, a lot of technical questions and commercial questions from market, and some of them are thought against us why we are, dedicating on the research of back contact rather than TOPCon. Well, we have been doing a lot of research and we have been doing a lot of in-depth and comprehensive analysis in terms of the power improvement roadmap for both TOPCon and back contact cell. Say in this graph, you are able to see that, all these figures are quite real, and these are from our hardcore research team. Well, say today in the market for TOPCon, basically what people are delivering is about 630 watt, as you can see on the left-hand side here. And what we have been delivering to the market on average is 655 watt. Say this is our current stage. This is our fundamental, power beam that we are able to deliver to the market. And we have, several research outcomes that we are able to, use to empower the further power improvement of both TOPCon and HIMO 9, say back contact. You will be able to see that during the process development and technology development, if you are able to apply the same set of technology, for example, you are able to improve your metal paste resistivity, you are able to use multi-cut, interconnection technology as to change the format, the module format technology, and you are able to use a premium, high quality, lifetime silicon wafer. If you all apply the same set of common technology to TOPCon and HIMO 9 at contact, our result is that at all time, HIMO 9 can reach a level to beat, TOPCon for at least 20 to 25 watt for the same piece of module. Say if you have the same dimension of the module, same dimension and same size of the module, same area, for HIMO 9, you are able to reach, say, by the end of the year, 660 watt. But in terms of TOPCon, I would say that the maximum by the end of this year will be 640 watt. And you are able to see that if we apply the same set of technology, then HIMO 9 will reach a maximum power potential, which is unbeatable for TOPCon. Saying that, if you look at the graph again here, let's focus on the graph on the right-hand side. Well, if we apply the next generation step, that we are able to reach 670 watt, and we apply the same set of the yellow figures here, and we should be able to reach 650 watt for TOPCon. So as we are applying all these technology, say we do an apple to apple comparison, and we compare the same power at the same time frame, say today compared to today, then we are quite confident to say that BC should lead the power advantage by 20 to 25 watt by all time, no matter it's in the end of 2015 or the end of 2026, or maybe in 2027. We are quite confident to say that we should be able to lead by 20 to 25 watt. Well, the second quite interesting potential or the technical advantage from back contact is that due to the fundamental feature and theory of back contact cell, the anti-hotspot quality and the anti-hotspot feature is much stronger in comparison to PERC and TOPCon. We demonstrated two sets of values and numbers and testing results from to Ryland and on our own testing project somewhere in China as well. Well, you are able to see that, under the same STC condition, where the irradiance is 1000 watt per meter squared, then for PERC and TOPCon, your hotspot temperature, when you shaded one complete solar cell of your module, that hotspot temperature will reach between 160 to 170 degrees C. But for HIMO 9, the maximum, the hotspot temperature, what we have recorded is 140 degrees C. Well, that substantial temperature difference may occur and result in a substantial, severe wiring hazard. In another example, where we have our outdoor testing project on your right-hand side here, where you use your infrared camera to do a comparison, and you do your infrared where you have an infrared, photo, and your irradiation is about 550 watt per meter squared. That's roughly, 10 a.m. in the morning, or probably 4 p.m. in the afternoon. Well, for TOPCon and PERC, that hotspot where you have your complete shaded cell, that hotspot temperature is about 106 degrees C. Whereas for the same shaded cell for HIMO 9 and back contact, that temperature is about 43 degrees C. So the influence and the impact is that what I would like to deliver is that, where you have your solar panel installed in your solar project, somewhere in the desert or somewhere in the middle of nowhere in Australia or Europe, they will be installed most of the time on a tracker system. Perhaps they're going to rotate from the east to the west 365 times for a year, straight for 30 years time. From time to time, some of these ribbons and the soldering points, it may got loosened. For 30 years time, anything could happen. When this unfortunately happens, maybe the occurrence and the possibility is probably, say, for example, 1 in 1,000, 0.1%. that 0.1%, it may occur, and no one will be able to mitigate or completely mitigate the possibility for a hotspot. What I'm trying to say is that using a high back contact cell, using a back contact technology, we are able to substantially minimize the impact of a hotspot when it unfortunately occurs over 30 years operation. Because in this 30 years time, things could happen. What we try to do is that I may not be able to completely mitigate the occurrence of the hotspot, but I'm able to mitigate or minimize the impact when a hotspot occurs. So for bad contact, traditionally, people may think that, for bad contact, you put all the fingers and all the metal contacts to the backside. What would be the bifaciality factor? Well, basically, if we reflect on our history, where Siobhan has mentioned in his session, in 2001, where bad contact technology first came out in the market, no one would predict that you are able to use a back contact for utility solar farm. Back then, in 2001 till 2010, all the back contact modules and technologies were only deployed to rooftop project and premium rooftop project. Well, there's a fundamental reason is that you have absolutely 0% bifaciality factor. Well, to enable the utility deployment of back contact technology, we have done a lot of research and we applied this research outcome to our product development. Well, we have been substantially improving the bifaciality factor. We have, surprised the market. In 2024, we have been able to reach 65% for the bifaciality factor. And to the end of this year, we are able to reach 75%. And of course, we have some solution and some technology to further boost the 75% bifaciality factor to almost 80% bifaciality factor. But this may come in the future as well. So this is a game changer for the utility market, which enables the deployment for utility ground mounted projects where bifaciality factor gives you a much higher, investment outcome by providing and offering a boost from the reflected light from the rear side and fully utilize the reflected light to generate additional power by possibly by 8% or some extreme cases more than 15% of your front power as well. But in our future roadmap, we will be able to further, optimize and improve the metallization and optical layer innovation to further push the bifaciality factor to 80%. So there's one figure that I would like to share with you as well. As you may know that because we have been moving all the metal contacts to the backside, there will be in theory, there will be a difference in terms of the bifaciality factor in comparison to TOPCon PERC or back contact cell. Well, in the market, we are able to see that for TOPCon, say, for example, you have an 85% bifaciality factor, and for back contact HIMO 9, we are featuring at this current stage 75%. But what would be more valuable and more important when you install your solar panel in the outdoor? What's more important is that the front power, the sum power of the front and the rear, or the bifaciality factor. So we have done some analysis, which I would like to show you today. There is an assumption that for the TOPCon, at the end of the day, by the end of the year, you will be able to reach about 640 or maybe 645, and for back contact cell, 670 watt with a bifaciality factor 75%, which is 10% lower than TOPCon. If we apply this formula on your bottom left here, you do an analysis and calculation by assuming the front side is receiving 1,000 watt per meter square, where the rear side you have 10% albedo factor, and you have you will be able to receiving 100 watt per meter square from the backside, which is quite typical to cover most of the applications from most of the continents. But in this general application and general scenario, you will be able to see that the sum power of TOPCon and HIMO 9 is about 25 watt power difference in terms of the sum of front and rear, despite the fact that I am at a disadvantage of 10% bifaciality factor. So that brings us to a story that what is more valuable. Now, I would say that the more valuable thing is the sum power from the front and the back at the same time. And that contribution and that 25 watt contribution mainly comes from the 30 watt power difference from the front side, which is quite surprising to us when we do this analysis in our outdoor testing projects. So we have been discussing quite a lot in terms of technology, product development, and science. But at the end of the day, what brings to the end as a customer value for utility ground-mounted project is your levelized cost of electricity. Because we believe that for most of the utility ground-mounted project, at the end of the day, it's an investment for 30 years' time. By applying a high technology and advanced technology, it has to come down to additional value to the customer. That would be your LCOE. So if we look at all these little formula here, which I'm sure that Chris Noyes will come to this formula again in his session, what you aim to do is to minimize all the red terms at the top of the equation and try to maximize the green terms at the bottom of the equation. But if, for example, if your power of the HIMO 9 back contact module is 30 watt higher than your TOPCon module, effectively for a say 100 megawatt project, you are able to reduce the amount of cables, trackers, DC combiner box, inverters, and all that. Basically, you are able to substantially reduce the balance of system cost as one of the red terms here. Whereas due to HIMO 9, the back contact technology, it features a much lower advanced temperature coefficient, which indicates that you will generate more power when your module is at a high temperature, say 50 or 60 degrees C, when you're operating outdoors, which is quite general, where your module temperature is generally 20 degrees C higher than your ambient temperature. If you do the calculation for 30 years time, you will be able to recognize that the lower temperature coefficient from the back contact technology will result in a much higher electricity yield. Plus, in addition, we are able to offer a much lower linear degradation coefficient for, let's say, 0.385% per year for back contact technology. When you add all these figures together, you'll be able to realize that, for the green terms at the bottom, you will be able to substantially increase your electricity yield and your energy yield for 30 years time. When we do pull all these figures together, and we have demonstrated in several of examples of our testing projects, which has been scattered around the world. Some are in China, some are in Europe, and some are in Australia. We are able to demonstrate that the levelized cost of electricity is able to reduce by at least 3.8% by only applying, HIMO 9 back contact technology. And what's more important for an investor is that your IRR, your internal rate of return, will be boosted by 5.3% for 30 years time, which could be for absolutely, it's going to be a deal breaker when you are doing a massive investment for utility ground mounted projects. So I briefly walk you through all the fundamental reasons why we are doing HIMO 9, why we have been invested billions of dollars to develop a back contact technology, which is not expected to be quite successful maybe 2 or 3 years ago. And I have been, walk you through about what we have been doing, what we are gonna see in the future as our vision that back contact technology will be constantly leading the competitive technology TOPCon for 20 to 25 watt in no matter which time you are referring to. And at the end of the day, due to a anti-hotspot behavior, high electricity use behavior, we are able to boost your internal rate of return for investment project. So we strongly believe that now we are able to transform and convert the science power in the lab to a power that is be able to benefit the vast majority of our public, which is highly accessible and deliverable and available to all the utility ground mounted projects. We are believing that HIMO 9 and back contact technology will be a ultimate solution to boost the customer value when we are still sticking in a single junction technology. So thank you all. This will be a brief introduction and a brief presentation about HIMO 9. Later, I will pass on to Christos, and we may be having some discussion in the later session. Thank you.
Thanks, Alex. I think this was a very nice presentation. So I have two questions for you, Alex.
So please.
Okay, great. So, you covered a lot of portion of your presentation discussing the, the hotspot problem, or, how back contact is less prone for hotspot. So it has higher shading tolerance in general. So how much of this better shading tolerance has relevance in utility applications? Because we are now talking about the utility for BC, right?
So thanks for the question. Let me try to briefly, assess your question, and I'm just sharing my views on utility ground mounted projects, right? Yes, you're right. For utility project, unlike residential distribution projects, you don't have a tree, and for most of the time,
Yeah.
you don't have a huge chimney on your rooftop. For utility, I don't see that happening. But however, having said that, we have been doing a lot of site review and site visit around different countries. What we surprisingly seeing is that for most of the ground mounted projects, because it's in the middle of nowhere, your operation and maintenance is not happening every day. It may happen every quarter, and generally for these ground mounted projects, the site area is quite dry, which you may have a lot of dust. What we have been seeing is that you are having a dust band at the bottom of your solar panel, and you are having some bird drops because no one is driving the birds away. You have some bird drops. In some extreme cases, one piece of the solar cell, of course, it's a half cell, it's completely shaded by bird drops, or one bottom row of your solar panel is completely covered by your dust band. When this happens, say, for example, at one cases where you have for bird drops, right, which is quite common for utility project. If one of your solar cell is covered by a bird drop, it's not generating anything. It's not absolutely not generating anything. But for say PERC and TOPCon, if you have one cell shaded, which indicates that that entire string is completely not generating anything. And in fact, all this electricity, where does it go? Well, for conservation of energy, Electricity is either goes to electricity or dissipated as heat. If it's not collected as electricity, it's gonna be dissipated as heat to your shaded cell. All the shaded cell will dissipate all the heat, which
Right.
as a result, it's gonna be improved. It's gonna be increased to maybe 160 degrees C, and that 160 degrees C for long term, it may burn your back sheet and it may melt your encapsulant. And for sure, at that high temperature, for some instance, it may loosen your metal contact between your solar cell metal and your ribbon. And when that happens, it's going to run down.
Great, great. So very quickly, one more question. You presented this technology progress, how logically you went to back contact, but if you look at the recent market, a few companies are actually presenting the TOPCon Plus, which is rare polyfinger, as a potential alternate to BC. Just they say that with this you don't need BC, so the gap is so little. Can you briefly, in one or two sentences, can you say something on that?
For sure. So we have done a lot of analysis in terms of theory to improve the efficiency of TOPCon and BC as well. As you said, the polyfinger and the half cell preservation, all these technologies they are trying to solve your defect that relates to your VOC. So if you apply all these technologies that we have mentioned, the polyfinger and the half cell preservation, the edge preservation, you are improving and preserving all the defects on the surface. It's either the front surface or the edge surface. Well, at the end of the day, you will have a ultimate high VOC. But what next? You still have your metal contact for the front side, which introduces your shading from your metal. To further improve that, you are gonna have to find a solution to address all these losses from a metal contact. As I mentioned in my presentation, you have two ways. Either you move it to the back, or you find a transparent metal, which is not really possible to our universe. So my answer and my understanding is that for TopCon, ultimately, you will have a high VOC, but you don't have an ultimate high ISC, your short circuit current. But for BC, you are able to address both of them. So at the end of the day, you will be able to maintain that 20 to 25 watt power gap between BC and TopCon, regardless of what technology you are applying to TopCon.
Cool. Thanks. Thanks for this insight. So then probably there could be some questions in the chat window. So please try to answer these questions while I will continue with Christos. So